Good morning, ladies and gentlemen. Heartiest greetings to all attendees present here. Welcome to today's webinar on Mastering Log Analysis with AeroGCS, Gaining Actionable Insights. We are thrilled to have you all join us today as we dive into the exciting world of drone technology, groundbreaking solutions provided by AeroGCS. My name is Vishakha Vinze, and I'll be your moderator for today. As a leading technology company, PDRL specializes in providing the finest technology stack to help business enhance their productivity and efficiency. AeroGCS is a perfect example of this commitment. Our presenter, Ms. Kanchan Borade, is an expert who truly understands the landscape of drone technology. She has devoted 6 years to crafting impeccable embedded software solution, showcasing her mastery in creating efficient and seamless software. With 4.5 years navigating the dynamic world of drones, Ms. Kanchan has been at the forefront of advancements in the cutting-edge domain. Embracing the role of knowledge disseminator, Kanchan has spent 2 years contributing to academia, sharing valuable insights with the next generation. Ms. Kanchan's journey is propelled by her unwavering curiosity, passion for innovation, and commitment to continuous growth. We are excited to have her share her experience, insights, and expertise with you during this webinar. Our industry experts, Mr. Dhananjay and Mr. Aniket, will be joining us to address these queries to the audience. Prior to commencing the webinar, I would like to mention a few points. Firstly, today's session will be recorded. Secondly, I would like to request you all to keep yourself in mute. If you have any questions, kindly type them in the chat box and we will address them once the presentation is completed. And now, without further ado, let's start. Over to you, Ms. Kanchan.
Good morning. Welcome all attendees to today's insightful webinar. My name is Kanchan Borade and I'll be host for today's webinar. As we know, in the rapidly changing landscape of technology, drones are the game changers. Or we can say the game of drone has been started. In every sector, we see drones like agriculture, construction, environmental conservation, infrastructure inspection, disaster response, media, survey mapping, etc. Drones' real potential lies not just in their flights, but in the data they collect. Today, we will discover how drone log analysis gives us a wealth of information. Data has become the new gold of this era, which is why it is essential to be able to harness the information collected by the drone during the flight. It is possible to guide the decisions, improve operations, and spark innovation using the drone's log. And using the drone data, which is composed of flight parameters, sensor readings, and the spatial information, which will guide to take the decisions and improve the further developments. Each time your drone take off, it records the wealth of data. Drone logs contains the details on your drone flight path, altitude, speed, and many more information. Understanding how to interpret the binary log can help you to improve your drone performance and prevent the accidents. So let's see the types of logs which can be recorded by the drone. So these logs are collected by the drone from its power on to power off cycle. There are multiple types of logs that can be collected by the drone. As we know, there are multiple sensors, multiple hardware components mounted on the drone. So all are responsible for performing their actions, and those logs are getting recorded by the flight controller into the SD card or in the memory of the flight controller. So these flight logs are recorded into .dat, .txt, .csv format. That is the file extension, we can say. Then the telemetry logs, those are recorded in the binary format, in the log, and in the txt format. Then we have the sensor logs, which are recorded in the DNG, TIFF, JPG, or in the binary format again. Then the GPS log, those are recorded into GPX, NMEA format. Then IMU, you must be knowing IMU, roll pitch yaw. Those logs are recorded into binary file, then the CSV and the TXT file. Then the remote control logs. Those are again recorded into binary format, then the log and TXT format. Error and debug logs, then the weather environmental data logs. Those are again recorded into CSV and the TXT format. Geofencing and the flight restriction logs. And geospatial metadata logs. The specialty of geospatial metadata logs are recorded into JSON format, which are very easy to decode. And the data transfer log, those are recorded into logs and the TXT format. So yes, these are the types of the logs which are being recorded by the drone and which will help us to analyze the data. Now, how this AeroGCS and logs are interconnected. Firstly, those are not aware of AeroGCS. I'm sure you are aware of AeroGCS, but let me introduce what AeroGCS is. AeroGCS is the mission planning software which is developed by PDRL. So here what we do, we give the mission plan in various format. Like you can plan the mission for survey, you can plan the mission for spraying, then the circular survey you can do, then we have the corridor survey, then waypoint to waypoint mission planning is also there. And by taking the flight, just by a simple click, you can take off your drone and you can perform the number of landings using AeroGCS. All kind of logs are recorded by the AeroGCS once you complete the flight. So AeroGCS is able to record the logs in .csv, txt, log, and the JSON format, and the binary logs as well. Now this CSV, TXT, and the JSON format log can be seen under the project and the plan section. AeroGCS allows you to see and download all the flight logs under the plan section if you have taken the complete flight. Remember, you'll have to take the complete flight. Complete flight means from takeoff action to the land action. So those logs will be recorded under the plan which you have done. These logs consist of all the flight related information. Vishaka, next slide. Yeah, so this is how it looks like in AeroGCS. So all the flight related information like altitude, speed, battery, latitude, longitude, then the roll, pitch, yaw, the status text thrown by the flight controller are recorded inside the AeroGCS and that are represented with the graphs with the help of AeroGCS again. Now, the beauty of these logs are, this log consists of the crucial information like the project name and the plan name, and at what was the exact start time and the end time for the flight. So selectively, you can analyze those logs from the start time to the end time. Yes, so these are the roll pitch, altitude, and the battery and the distance parameters. And you can see the table where all the parameters and its value are recorded. Yeah. So, as we have seen, CSV, TXT, .log, and the JSON. Those are those formats are the readable formats, and they are very easy to represent into the graphical format. Those are very easy to decode. But whereas binary logs must be decoded before they can be analyzed, those are very difficult to analyze as binary. When I say binary, so those are into machine readable format. So firstly, let's understand what binary logs are. The drone's binary log, they are often referred to as a black box, or the flight logs, which is a file that records the variety of data information related to drone's flight performance. And again, as I said, those are recorded into machine readable format, that is in zeros and ones. The content of drone's binary log can vary depending on the manufacturer, the type of the drone, and the feature it offers. However, the typical information that might be found in a binary log, which includes the flight telemetry, sensor data, then the remote control data, all the kind of system events and the error and warning messages, motor and the servo data, GPS communication data, and the flight mode transmission data. So all kind of data are recorded inside the binary file. That's why it is very important to decode it and analyze it. These logs are very crucial because whenever your drone crashes, they provide the valuable information about what went wrong during the flight. By analyzing these logs, we can investigate and identify the root cause of the crash that it took place, and we can take the step to prevent a similar incident happening from the future in the future. For example, if a crash was caused by a mechanical failure, the manufacturer can use the data from the binary log to improve the design of their drone and prevent the similar failure from occurring in the future. Yeah. So as I said, binary logs are in the machine readable format. So it needs a decoder to decode it. Same we have implemented in the AeroGCS Kia, that is log analyzer tool, where we will be able to see the actual graph of the flights which are coming from the binary file and their respective parameters. The plots for the flight logs can be used to analyze the general vehicle information. The plots are meant to be self-explanatory, but it takes some experience to know what ranges are acceptable. Like as we know, the ranges of motor that should start from 1000 to 2000. So all this kind of basic information we should have to analyze those data. We should know the range of roll, pitch, and yaw before analyzing the data. So yes, you should be expert enough, and you should be knowledgeable to have all the basic information regarding the drone. Then and only then you can analyze those data and those graphs. AeroGCS Kia Log Analyzer is a very simple tool. It's very easy to use. It provides the option to the various data visualization. It provides the graph for the multiple parameters with the distinct colors. It provides the information about the error and warning during the selected time. And it enables easy viewing of the flight modes. All the flight modes like loiter, auto, stabilize, all can be seen under the plots. So let's have a demo of the same. We'll move for the demo. We'll see how to use the log analyzer in using AeroGCS Kia. So let me share the screen. Is my screen visible, Vishaka?
Yes, it is.
Okay. So this screen represents the AeroGCS Kia. This is the dashboard of AeroGCS Kia. It is very simple to use. So for log analyzer tool, you just need to click on the left hand side bar menu. There you'll find the log analyzer option. Here, this screen of log analyzer where you can select the binary file which you want to decode or which you want to analyze. We have also given the download button where you can download the logs from the flight controller. If you want to download the signature log from the SD card, yes, they can be downloaded if your firmware is a secure firmware, or else you can easily download the binary file if your firmware is plain. So in both the cases, we have given this option to download the binary logs from your SD card or from the drone. So this is the option to select the binary file. So let me select the file, any file. So yes, I have selected one binary file which was related to spraying mission. So yes, selected the binary file related to spraying mission, which was done with the help of AeroGCS. Here, as I said, you can see the flight modes, that is loiter, guided. All the information will be represented in the graphical format on the screen. All the information, status text messages or error and warning will be given. On the right hand side, you can see the number of parameters here. Whatever you want to analyze, you can select it accordingly. Let's see. I want to see how the altitude was there. What was the altitude performance in my mission? So I'll just go under the barometer and I'll select the altitude from the barometer. So yes, this is how the altitude performance was. So here the graphical information is represented for the altitude. Same if I want to see, if I want to compare the altitude of the barometer and the altitude which was given by the GPS. So yes, you can see the difference. We have differentiated two different graphs using two different colors. So yes, this is the beauty of this log analyzer. Here on the upper side, you can see the multiple options like there is an option if you want to see the mode continuously, you can check it or you can uncheck it. Same for the errors. Then if you want to see the events, all the events which were happened at the time of flight, you can see that. Then the cursor value, if I select the cursor value, I'll be able to see the actual value on the graph. What was the value of barometer and the GPS at what time? So yes, once I enable the cursor value, I'll be able to see the values on the graph. Then I have a data table. All the parameter are given in the data table. What was the value of a particular parameter that can be seen under this table. Even we have provided the table filter. Once you click on the table filter, you'll be able to see the four options where if you want to deselect all, you just need to click on the invert select. Now I just want to see the value of barometer, what what was the value of altitude under the barometer. I'll just accept it, and accordingly those value will get filtered. So this is how the table filter works. Even I have a GPS trailing where I'll be able to see how and how was the plan given by the user, how my drone has flew on the ground, what was the actual path. So yes, that can be seen under the GPS trailing. So this is the basic introduction of this log analyzer. We're going to see the number of case studies, how to use this log analyzer to analyze the multiple binary file. I have created 8 different situations. I have 8 different situation binary files where you will be able to see the graph, and I'll tell you how to read those graphs using which parameters. Okay, so let's start with the case one. I have already selected the file, that is spraying GCS failsafe binary file for the case one. So yes, let's start with that. So this is the spraying mission which we did on the ground. So we just need to see if everything went well or not. So how to see that? As I told you, as we have seen, we have selected the altitude of the barometer, and same we can compare with the altitude of the GPS. So yes, if you want to check the altitudes, you can select the barometer altitude, and at the same time the GPS altitude. You can compare those altitudes. Even you can see when the auto command was given, when the actual mission has been started. Now here you can see the value of the altitude. It was around 0 initially. It was 0 initially. When there was a loiter mode given by the GCS, still it was 0. Now you can see the guided mode is given by the GCS, and then auto mode is given by the GCS. Still it was 0. Then it started climbing up, and it was achieving the altitude given by the GCS in the mission plan. And this is how the altitude was achieved, and it followed all the altitude which was given by the mission, or which was given by the GCS. You can see the modes given by RTL when it was finished, when it was at its last point. And then we can see the events. Land was completed or at this point, and again the drone has been disarmed. So this is about altitude, right? But if I want to see the position, the actual position, the behavior of the position, I'll go to the altitude section. I'll see the role and what was the desired role. So again, I can compare the role which was followed by the drone and what should be the desired value of the role. So you can select these 2 parameters, desired role and the actual role, under the attitude section, ATT. Same for the desired pitch and the actual pitch. As I said, we have differentiated all the parameter with the distinct colors. So here you can easily compare the value of the desired role and desired pitch with the pitch. And again, we have the desired yaw and the actual yaw. So we should have this prior information before analyzing the behavior of the drone. So yes, we should know the range of roll, which lies in between -90 to 90. Then the value of pitch should be in between -180 to +180. And the value of yaw, you must be knowing, it should be in between those 0 to 360. So accordingly, you can read those values The y-axis, we have the multiple y-axis of the multiple parameter, while x-axis is constant because on x-axis we are showing the time. Okay, so accordingly you can analyze the value here. Now what should be the conclusion? Let's stick to only one parameter, desired role and actual role. So here you can see the blue color, uh, it's showing the desired role, which is a quite good graph. But you can see in actual role, which is followed by the drone, it is getting fluctuating. It is fluctuating. But yes, this is acceptable. This is an acceptable behavior by the drone, because when we fly the drone on the field, there are various conditions which we face on the ground. There could be environmental condition, there could be like high wind, there are various parameters. So this much of fluctuation is acceptable for the roll and pitch or yaw. But it shouldn't be, that angle should not be differ by 90 degree or more than 30 degree. So here, if you see the value on the cursor, the desired roll was 5.9, and actual roll, which was followed by the drone, was 6.2. So yes, this value is acceptable. Okay, so I can conclude, yes, this flight went well for the spraying mission. Okay, so this was my case number 1. Let's move further for the case 2, where I have a scenario for the motor and the ESC fail. So firstly, I'll select the file which is with me for the motor and the ESC fail. Now, how to analyze it? So before I conclude, or before I'm saying that this file is motor and ESC fail, but many of the user must not be knowing what could be the issue or what could have happened. So before commenting anything, I have just selected the file. Let me tell you the scenario behind this. It was a quadcopter that got crashed, and it caught the fire during a mission, and half of the part has been burnt. Initially, drone flew well and it was following all the command, but suddenly it started losing the altitude very rapidly, and it struggled to keep its level. And the value of it was a mix of values of roll, pitch, and yaw, and there were no throttle response from the RC. So when I say there was no throttle response and it was unable to keep its level, so yes, I can go for the motor parameter in this case. So I know which channels was used. So that was C11, 12, 13, and 14. So these are the motor performance. So before selecting, as I said, it flew well initially. So these are the commands given by the GCS: loiter, loiter, and then the auto. It flew well. Again, it was flying in the auto mode till this, but suddenly it got some messages like compass was unhealthy that time. It was failed to initialize, and that got fail-safe detected because of the bad variance. So let's have the motor selection: C11, 12, 13, and 14. Generally, the value of motors or value of PWM which are configured, that should lie in between 1000 to 2000. As there were no message from the flight controller when it was falling, as I said, there were no throttle response. So let's see what was the battery voltage at that time. So you should go to the battery BAT and need to select the battery voltage. So I found this okay. You can see the graph. This is quite good. So I don't think it could be the battery or the battery is problematic. There were no EKF variance found. So if there is no variance found and the battery voltage was fine, so instead of selecting the motors, let's check the vibrations. So I'll again go to the vibe and select vibe X and Y and Z. Here also vibrations are good. As see how to analyze if vibrations are good or not. You just need to check the z-axis. Your z-axis shouldn't touch to the x and y axis. So initially it went everything well. As you can see, there is no touching of z-axis to x and y axis. So yes, I can conclude vibrations were okay. So again, I'll deselect those y value. And again, I'll go to the C11, 12, 13, and 14. Now let's monitor the value of C12 and 14 and 13. See here you can see the values of motor are touching to its minimum value. That is 12, it is going below 1200. So that could be around 1100 or more than that. So they are touching to its minimum value. Here you can see those are actually performing well because those values were in between almost 1400 to 1800. So here, as I said, initially flight went well, but then suddenly it started losing its altitude because these values are touching to its minimum value. So that's what we can conclude here. That if those values are touching to its minimum value, there must be some wrong, there must be something went wrong with the motors. This, as we have discussed the various parameter for this file, let's summarize it one by one. We have checked the vibration value, those were okay. We have checked the battery voltages, though that was also okay, because as I said, the battery or that drone burned, uh, I mean during the flight it caught the fire, so it burned. So that wasn't because of the high vibration, that wasn't because of the battery voltage. So I need to see what was the roll pitch and yaw at the time of falling, at the time when altitude went, uh, altitude was losing. So I'll see the value of roll pitch and yaw. So here you can see the value, the roll which goes from almost from positive value to directly to the negative value, almost to minus like 60 to 70 degree. And pitch as well, it also went from positive value like almost from 5 to 8 degree to minus 20 25 degree. Here you can see, so which indicates a strong tilt from the front side. As you let me brief about this roll pitch and yaw. As you know how pitch behaves, pitch goes in forward and the backward direction, roll left and right, and yaw, it moves around itself like in the 0 to 360 degree. So when I say roll goes from positive to negative and pitch as well from positive to negative, then I can conclude that it is the strong it is a strong tilt to the front and the left side. which could mean there is a motor failure from one side. It is a quadcopter, so this motor could be motor 3 or motor 4. So this is how I can conclude. So why this could have happened? So that could be because of the large propeller, because initially it went well, initially that drone flew well, but if you have connected the large propeller instead of, like, if you have connected the 15-inch propeller with the 29-inch propeller, initially it will gain way too high, but which will cause a massive fluctuation in the output. So yes, this could be the problem. So if the user had used the smaller propeller, that drone couldn't, hadn't crashed that time or hadn't burned out. Okay. So this is how we can conclude the things. We need to check the various parameter before concluding anything. As we have seen the various parameter: vibration, altitude, roll, pitch, yaw, then the acceleration, everything we have seen, and we concluded there was a problem with the motors. So yes, let's move forward for the next case studies. Next case, it is the vibration related case study. So yes, I selected the vibe.binary file. I'll tell you the scenario behind this file as well. This was planned to fly in the automation. So it went good with the waypoint number 1 to waypoint number 2. As you can see, auto mode is given, then the stabilize auto, everything went well from 15.9.22 to 15.10.22. But after it started to go into uncontrollable climb. So when I say uncontrollable climb, let's select the value of altitude and select the value of altitude. See here, you can see everything went well for the waypoint number 1 and waypoint 2. But after reaching to the waypoint number 2, it uncontrollable climb, you can see on the graph here. It directly went from 20 to 60 almost. Then user tried for the RTL by using the radio, that is RC, but still there was no response. As you can see, after the RTL command also there was no response from the drone, and it was still increasing the altitude. Then it switched to stabilize mode. As you can see, it switched to stabilize mode. Then it got the control. So it was dropping the altitude. You can see the drop of altitude. Again, it switched to the land, but again, it climbed to fly more. Again, it controlled by the user using RC, again from land mode to RTL mode. And yes, that got controlled, but again, that was with the crash. It resulted into crash only. So here we can see GPS, everything was okay with the GPS. Glitch was detected that time, but still it was working fine because it was achieving the altitude, it was following the position. It was the issue with the altitude only. So whenever there is an issue with the altitude, the actual problem is not with the GPS, but the problem is the vibration. That is the vibration EKF error. Vibration compensation activated into uncontrollable climb. So in this case, you'll have to inspect all the hardware component mounted on the drone, all the connection you need to check. You need to check the balancing of all the propeller, no matter what they are. There should be better isolation of the GPS from the compass. There should be better isolation of the FC on the drone. So before taking the flight in auto mode, you can simply hover into in the alt hold mode for a minute and observe the altitude and the vibration behavior, and accordingly actions can be taken. So let's select the vibration values as well, X, Y, and Z. As I said, how to check if vibrations are good or not. So the vibration Z axis shouldn't touch the vibration X and Y axis. Here you can see there is a mixing of X, Y, Z axis. So those are very bad vibration, which are not at all acceptable for the flights. It is the very common problem for the multi-rotor vehicle. It is therefore important to keep an eye on the vibration level, improve the setup if needed. So we can conclude high vibrations are not good for the flight. In the lower vibrations, yes, you can take the flight, but again, that are not recommended. So just by hovering the drone, you can check the vibrations and accordingly you can take the decisions. So yes, this is what for vibrations. Let's go for the fourth case study. Battery fell. Here you can see there was a bad variance detected. That means there must be some failsafe which was triggered, and that was a crash detected. Crash may happen due to various reasons. So let's select the battery. Firstly, select the altitude value. Here you can see it got dropped to the 0. And let's select the battery voltage. Yes, initially it was 10.5 or almost 10.7, then 1, then suddenly it got dropped at, at this point. You can see it suddenly got dropped, and got resulted that resulted into the crash of the drone. It directly dropped on the ground. The failsafe was triggered in this case, but before landing, it got crashed as battery voltage suddenly dropped. You can see here. So before taking, so what should be the prior actions taken? So before taking the flight, the voltage and the current of the battery should be measured with the standard meters. Standard meters. This is very important. You cannot use uh, any unbranded meters to measure the current and the voltage of the battery. User should check the current sensor as well. The sensor which is connected to your battery, that is current sensor. So yes, that is also should be taken into consideration. So yes, by monitoring the battery voltage, you can check the battery statistics. Next, move for the fifth case studies, GPS glitch. Yeah, so before going for the GPS glitch, Vishaka, we have one video. Can we show that video?
Yes, sure.
So this was a spraying drone flying on the ground, and it was not able to maintain its position due to GPS. There were less satellites at that time while taking the flight, so it was unable to maintain its position, and suddenly it got a GPS glitch and it got hit on the tree. You can see in the video. Yes, and that got crashed and resulted into broken. It's one of the arm. Yeah. So why this could have happened? So again, before taking the flight, you need to monitor the number of number of satellites present on the ground or on the field. What are the minimum number of satellites those are required to take the successful mission flights are greater than 10. There should be number of satellite which are greater than 10 are acceptable for the mission. And HDOP value, the value of HDOP, the good value of HDOP lies in between 1 to 2. So here you can see initially in the auto and the stabilize mode, everything was going good. Then suddenly the GPS glitch was detected and it got heated on the tree. Here you can see the glitch was detected. Here you can see the value of HDOP. You can monitor the value of HDOP here. It was 0.6 only. So when that glitch was happened, the value of HDOP was very poor. So before taking any flight, you'll have to monitor the number of satellites and the value of HDOP. Okay. Yes. Next case is for compass. I'll tell you the scenario. We had this binary file. It was a hexacopter spraying drone. Initially, flight went well, but for the longer flight, it got the message as large change in the magnetic field. It is 49%. So message itself explained that error is related to compass, also magnetic field interference. So we'll select the parameter accordingly. Usually external compass, as we know, there are multiple type of compass can be connected on the drone. One is the internal compass and others are the external compasses. So those external compasses are labeled as 2, 3 onwards, and internal maybe 0 and 1. So let's select the mag 2. We'll see what was the value of external compasses: mag X, mag Y, and mag Z. You can see here before selecting mag Z, you can see the value of mag X and mag Y, that is the internal compass, magnetic axis X and Y. Those are well, but when I select Z, you can see, okay, I'm just changing the color of Z axis. You can see the behavior of Z axis here. It was completely changed initially. It's completely changed. You can see this is highly affected, and this is highly affected by the current drawn. And this is nothing but due to the interference. Okay, so it is always recommended to perform the compass and the motor calibration before taking the flight, that too with all the setup. If you're flying the hexacopter, the compass, I would suggest the motor and the compass, ESC, all kind of calibration should be done with all the setup. You shouldn't directly remove the FC and perform all the calibration on FC, which is not at all recommended. So you may face this kind of issue if you don't do the calibration with whole setup. So yes, you should do all the calibrations and set all the calibration with the complete setup. This will help the compass issue you can see there is a big difference in the current drawn at the start of the flight and at the end of the flight. And this could also this could be because of the full load, because spraying drone, as I said, it was a hexacopter spraying drone. It could be loaded with maybe 10 liter or the 6 liter heavy payload. So yes, this could be the reason. And I would recommend, if you are using the external compasses, you can disable the onboard compass, which will avoid the interference. So if you use the external compass, it will give you the good stability and you will not face any compass failure error on your in your flight. Okay, next move for the seventh case study. Again, it is related to compass only, but yes, I'll tell you why this has happened. I'll tell you the scenario. User made the new version of his drone. What he did, he just changed his GPS with here 2 with the here 3, and after tuning and some of the calibration, he started flying the drone in the louder mode. Drone began to move in a big circle, and user tried to land the drone, started moving fast, but it's got started moving fastly. And when user stopped the motor, unfortunately, drone landed with the damaged landing parts. So yeah, what user has done, he just changed the GPS with GPS 2 with GPS 3. He initially he was using here 2, and then he replaced with here 3. Firstly, we need to see, if you are building the new version of your drone, it should be tuned, it should be calibrated properly. The placement of all the components should be done with the standard mechanisms. Let's have the brief analysis of this. So let's select XKF4. We'll need to check all the GPS, as it is related to GPS. That's why I'm selecting XKF4. What is XKF? Is extended Kalman filter. So I'm going to see what was the GPS velocity, what was the GPS position, what was the barometer test ratio, what was the magnetometer test ratio. So yes, I'm going to select SV, which stands for GPS velocity test ratio. Then the SP, which stands for GPS position test ratio. H is related to barometer test ratio, and M is related to magnetometer test ratio. And again, we're going to check for the IMU. I need to see what was the acceleration at that time, acceleration X and Y. This could have some problem with the GPS, but there seem to be, as we have seen, there is a GPS glitch, as we can see on the graph. It could caused by the electromagnetic interference also, because while mounting GPS 3, it could have been kept closer to the drone body, that is FC, and if FC internal compass is enabled, that could have caused the electromagnetic interference. You can select the HDOP value as well. Here you can see the value is very less, HDOP value. You can see these are the acceleration. V4, as I said, XKF, that is extended Kalman filter. MSM, as you can see, XKF4, that is VSV. SV is related to GPS velocity. It directly got increased to its highest value. Then you can see here magnetometer ratio. It got again hit to its highest value, and again the position value as well. So this is completely related to compass. Magnetic interference happened in between the GPS and the compass. So this is how you can analyze the magnetic interference due to compass. Okay. Next file is, yeah. So it is this this file is has been generated by us on the simulator only, because we wanted to monitor the value of the rangefinder mounted on the mm, drone. So scenario is the drone got heated on the building because the response time was very high for uh, for the obstacle avoidance. We connected to the drone. As we know, the axle max avoidance, that is maximum acceleration, it should be greater than the speed of the drone. And the speed of the drone, as we know, it is WP nav acceleration. Otherwise, sensor will fail to identify the obstacles and results into the collision. So yes, this we will go for the selecting the RFND, that is rangefinder value. You can see, you can check the distance as as it got crashed is heated to its maximum value. So before flying, the obstacle avoidance sensor which you have mounted on the drone, its position matters a lot. You should check the response time of the sensors as well. At the time of flying, the maximum acceleration value uh, should be greater than the speed of the drone speed. If drone speed is greater than the avoidance maximum acceleration, then yes, it will result into the collision. Okay, so this is how you can monitor the values of sensors as well using the log analyzer given in AeroGCS Kia. You can monitor the altitude as well. It got heated and it got crashed and it touched to the ground. Okay, so yes, that's it from my side. This tool will be available, this log analyzer tool will be available in a week for you all. Remember, it's not just about analyzing the data, it's about leveraging that knowledge to elevate your drone operation to the new height. So let's work together to ensure the safer flights, better performance, and smarter decision makings. Here, I request the audience, if anyone has a binary file which they want to analyze, can share with us. We'll try to analyze it. And yes, we are open for the discussions. Vishaka, over to you. Thank you.
Thank you, Ms. Kanchan, for this insightful session. I would request our audience, if you have any questions, you can type them in the chat box or you can unmute yourself and ask. There were few questions which were asked in the chat box. Mr. Aniket have already answered them, but if anyone has to add to it, you can do so. Thank you, Mr. Ali. We very much appreciate your participation in these sessions. and we hope all your queries were answered today. Once again, please feel to ask any questions you have.
Uh, I'm Ramesh Patil. I just wanted to ask, is there any function available in AeroGCS that can enable us to download the telemetry logs? Because in one of the analysis, I wanted the telemetry connections trend data from my whole flight path, like from arm to disarm, the percentage of the connection between the GCS and the drone I wanted, but I don't find this data in the data logs, and it is
Okay.
available in the telemetry logs. Is there any
Uh,
facility available in AeroGCS to download the T logs and analyze them?
you mean to T-log, sir, or uh, are
Yeah,
they
yeah, T logs
in
only.
CSV format as well? Because what we are
Yeah,
doing.
anything is fine.
Okay, sir, is screen visible to you? I'll show you how to download the logs from GCS.
Yeah, you just share
So,
the screen.
yeah. So here you just need to select the project under which you have done the mission planning. Okay.
To be honest, most of the flights I do in manual only, like 90% of the time. So I don't have the
So
plans that are created.
those are also available for the manual flights. Right now, I'm having only automatic flight, but yes, you
Okay,
just need to follow the same method. You just need to click on the view logs. You'll be able to see all the number of flights taken against the mission plan. And here
okay.
there is a download option. You can just simply download and you can save any of your folder, and those will be downloaded. Same method you'll have to follow for the manual flights as well. And if you
Okay.
want to move all the data on the cloud, so we have that facility as well. We have a AeroMake cloud platform where we save all the data, where we sync all kind of data. You just need to log in into your account on AeroMake. You just need to enter your AeroMake credential over here, and once you do it, you just need to check on the cloud button over here. You need to sync all the project present on your AeroGCS dashboard. If you say yes, all the projects, plans, and related log or the respective logs will be uploaded to the AeroMake platform that is on AeroGCS Enterprise. Yes, sir.
Yeah, got it. Thank you.
Thank you, sir. If anyone having the binary file, they can share with us. We can do the live analysis of the same.
All right. I think so. We are done with the session. I would like to thank Ms. Kanchan for this insightful session. And thank you all the audience for joining us today. We hope this webinar will inspire you and equip you with the necessary knowledge to harness the power of AeroGCS solutions. Let's explore the future of drone technology together. Wish you all the best. Thank you, everyone.
Thank you. Thank you all.